The bat occupies a place in nature that no other mammal has ever claimed. It is the only mammal capable of true, sustained flight, and it lives almost entirely in a world of darkness, sound, and memory. For millions of years, bats have shaped ecosystems quietly, emerging at dusk, vanishing before dawn, and leaving behind effects far greater than their size suggests. To understand bats is to confront how evolution rewards efficiency, adaptability, and intelligence rather than brute force or visibility. The evolutionary origins of bats trace back more than 50 million years to small, tree-dwelling mammals that experimented with gliding. These early ancestors lived in dense forests where moving through the air offered access to food and safety from ground-based predators. Over time, gliding membranes evolved into fully functional wings, transforming forelimbs into elongated structures supported by thin bones and flexible skin. This transition marked one of the most radical shifts in mammalian evolution. Unlike birds, whose wings are shaped by feathers and rigid skeletal structures, bat wings are living hands. Each wing contains elongated fingers connected by membranes rich in nerves and blood vessels. This design allows extraordinary control, enabling bats to hover, turn sharply, and fly slowly without stalling. Flight for a bat is not just movement, it is tactile perception. Wings feel the air, adjusting instantly to turbulence and obstacles. Bats diversified rapidly once flight was established. Today, they represent one of the most successful mammalian groups on Earth, second only to rodents in species diversity. They inhabit nearly every environment except extreme polar regions. From tropical rainforests to deserts, caves to city buildings, bats have adapted to conditions that defeat many larger animals. Physical adaptations reflect this diversity. Some bats are tiny, weighing less than a coin, while others possess wingspans exceeding 1 meter. Fur coloration varies from dark browns and blacks to bright whites and reds. Faces range from fox-like elegance to bizarre structures shaped by echolocation needs. Despite this variation, all bats share a common blueprint optimized for flight, nocturnal activity, and sensory specialization. Echolocation defines the bat's relationship with the world. While not all bats use it to the same degree, many species rely on it entirely. By emitting high-frequency sounds and interpreting the returning echoes, bats create detailed acoustic maps of their surroundings. They can detect insects the size of a mosquito, distinguish textures, and track moving prey in complete darkness. This ability rivals, and in some ways surpasses, visual perception. Echolocation is not a simple reflex but a complex cognitive process. Bats adjust frequency, volume, and timing based on environment and task. In cluttered forests, calls become rapid and precise. In open spaces, they stretch farther and slower. This flexibility reveals a high level of neural processing and learning. Young bats must practice extensively to master echolocation, refining their skills through trial and error. Behavior among bats varies dramatically by species, but social complexity is common. Many bats live in colonies ranging from a few individuals to millions. These groups offer thermal benefits, predator protection, and opportunities for learning. Communication within colonies includes vocalizations, scent signals, and physical contact. Some bats form long-term social bonds, recognizing individuals and maintaining group cohesion over years. Diet is one of the most important factors shaping bat evolution. Insectivorous bats consume enormous quantities of insects each night, providing natural pest control that benefits agriculture and reduces disease vectors. Fruit-eating bats act as seed dispersers, carrying plant genetics across vast distances. Nectar-feeding bats pollinate flowers adapted specifically to nocturnal visitors. Carnivorous and fish-eating bats occupy specialized niches, demonstrating the group's ecological reach. Survival strategies depend on energy efficiency. Flight is expensive, and bats must balance intake and expenditure carefully. Many species enter torpor, lowering body temperature and metabolism to conserve energy during periods of food scarcity. Some migrate seasonally, while others hibernate for months in caves where temperature and humidity remain stable. Predators include owls, snakes, and carnivorous mammals, but bats rely on timing and roost selection to minimize risk. Daytime roosts are chosen for concealment, accessibility, and microclimate. Caves, tree hollows, cliffs, and human structures all serve as shelters. Roost fidelity can be strong, with bats returning to the same sites year after year. Reproduction in bats is typically slow compared to other small mammals. Most species produce only one pup per year. This low reproductive rate reflects high parental investment. Mothers recognize their offspring through sound and scent even within massive colonies. Pups depend on maternal care for extended periods, learning flight and foraging skills gradually. The bat's role in ecosystems cannot be overstated. Insect control, pollination, and seed dispersal make bats foundational species in many environments. Without bats, insect populations explode, crops suffer, forests regenerate more slowly, and ecological balance degrades. Their absence creates cascading effects that ripple through food webs. Human interaction with bats has been shaped by fear, mythology, and misunderstanding. Bats have been associated with darkness, disease, and superstition despite being largely harmless. In reality, bats avoid humans and play a net positive role in human welfare. Habitat destruction, cave disturbance, and urban expansion pose far greater threats to bats than bats pose to people. Disease narratives have further damaged public perception. While bats can host viruses, they are not inherently dangerous. Transmission to humans occurs primarily through habitat disruption and wildlife exploitation. Killing bats or destroying roosts increases risk rather than reducing it by stressing populations and forcing closer contact. Conservation challenges facing bats are severe. Habitat loss, pesticide use, wind turbines, and climate change all contribute to population decline. Some species are already extinct, others are rapidly approaching critical thresholds. Conservation efforts focus on protecting roosts, restoring habitats, regulating chemicals, and educating the public. Why bats matter goes beyond ecology. They represent an evolutionary achievement unmatched by any other mammal. They show how intelligence, cooperation, and specialization can unlock entirely new ways of living. Bats succeeded not by dominating ecosystems visibly, but by integrating into them invisibly. In a world driven by light, speed, and noise, bats thrive in silence and shadow. Their story challenges human bias toward what is seen and celebrated. It reminds us that survival is not always loud or obvious. Sometimes it flies overhead unnoticed, reshaping the night one wingbeat at a time. The future of bats depends on whether humanity chooses understanding over fear. These animals have shared the planet with us since before civilization began. Their continued presence is not optional for healthy ecosystems. It is essential.